I wanted to talk about a very important allosteric regulator of glycolysis, and it's going to affect this step right here from, hang on a sec, there we go, from fructose 6 phosphate to fructose 1,6 bisphosphate, and it's going to directly influence this enzyme right here, PFK, or phosphofructokinase. And I should mention that it's only going to affect the liver. Okay, so what is this regulator? What's it called? Very good. It's called fructose 2,6 bisphosphate. Okay, good. Okay, remember, only the liver. Okay, so before we start, let's just pretend that this right here is the inside of a liver. This right here actually would be the plasma membrane, okay? And there are two kind of receptors based on fed or fast state. What are they? Yeah, your insulin receptor, which I've drawn here, and your glucagon receptor, which I've drawn here. And what is this protein, or what have I meant this protein to represent? Yeah, this is protein kinase A, and this guy right here, it's actually two proteins, right? Who's this one? Yeah, you're right. It's phosphofructokinase 2, and this protein right here. Very good. It's going to be fructose bisphosphatase, the guy who breaks down fructose 2, 6 bisphosphate. Okay, so let me see if I can do this. There we go. I've labeled it for us. All right. So let's begin. Just kind of want to put this up here. There we go. Okay. All right. So let's say that we are in a time of fed state. So in a time of plenty, and there's glucose all around the extracellular environment. Your pancreas is going to release a hormone called insulin, right? Uh-oh. This should say, sorry, don't know, kind of sleepy. This should say insulin. There we go. All right. So your pancreas is going to release insulin, right? It's going to bind, and is it going to turn protein kinase A on or off? That's right. It is going to turn protein kinase A off. And when that happens, PFK2, is it turned on or off? Right. Protein kinase A doesn't phosphorylate PFK2, and that means that it is, oops, I don't know what I was doing there. That means it's on. And that means that this guy, fructose 2,6 bisphosphatase, right? That means that this guy isn't going to be breaking down fructose 2,6 bisphosphate, so it's turned off. And so what happens here is that fructose 6 phosphate, right, which is building up, is going to be converted by PFK2, let's go down here, into something called, this is our enzyme, this is our allosteric regulator, right? It's going to be turned into something called fructose 2,6 bisphosphate. Okay, and fructose 2,6 bisphosphate is really important because what does it do? Yeah, it kind of sends a signal to phosphofructokinase to turn on. In other words, it's going to really push glycolysis forward, right? So that's what's going to happen when you have insulin binding. But what happens when you're in a fast state and glucagon binds? Let's go over that. So let's see. Can I erase this? I think so. Very nice. And good. Okay. So now we're in fast state, right? And glucagon is binding to its receptor here. What's it going to do to protein kinase A? It's going to turn protein kinase A on, right? And in turn, protein kinase A is going to do what to PFK2? Phosphorylate it. Good. And we know that when PFK2 is phosphorylated, that means that it's turned, right, it's turned off. And in turn, this guy, your fructose2 6bisphosphate, is turned on and it starts munching up fructose2 6bisphosphate, right? So that guy goes away. And what happens is, in this case, you're not going to get that signal to phosphofructokinase to turn on. And that kind of makes sense, right? Because when you're in a fast state, you don't want the liver to be providing energy for itself, right? This is the time that your body needs the liver to distribute glucose to the rest of the body. Your liver, remember, is very altruistic. So you don't want it to be doing glycolysis. You want glycolysis to kind of stop. So yeah, there we go. And let's now do a summary, okay? So when we have high glucose, what hormone is going to be produced? Very good. It's going to be our insulin hormone, which means that our PFK2 is going to be turned what? On or off? That's right, it's going to be turned on, and in turn, our fructose2 6bisphosphate is going to be turned off. Good. And when this guy is turned on, what does it help do? That's right, it helps to make more fructose2 6bisphosphate, right? And fructose2 6bisphosphate does what? That's right, it signals to phosphofructokinase to turn on, which turns glycolysis on, and it turns gluconeogenesis, the formation of glucose to be distributed to the rest of the body, turns that off. Contrast that with the fast state. So in fast state we have low glucose, right? So the hormone's going to be what? Let's change this. That's right, the hormone's going to be glucagon. And glucagon is going to signal to protein kinase A to turn PFK2 on or off. That's right, it's going to phosphorylate PFK2, which is going to turn it off. Good. And conversely, this guy is going to turn on, right? And this guy is going to start eating all of this guy up. So this is going to go down, right? And then what about PFK1? Well, there's no signal to activate it, right? So it's going to stay off. Glycolysis is going to increase or decrease. It's going to decrease, right? And what you get is more glucose being made, right? So gluconeogenesis increases so that the liver can send glucose to the rest of the body. Yep, and that is the summary of fructose2 6bisphosphate, which is a very important allosteric regulator of phosphofructokinase.